Assess 18 question 4. The pyramid has a square base as shown there, BCDE, and the sides are 8.2 centimeters, so I can do that. I'm told that X is right in the middle of the base there, right in the center, and the vertical height AX is 11.6. I've got to calculate first of all angle ACE, so ultimately I'm after that angle there. Now I've got an 8.2 there. I'm sure I'm going to have to use the 11.6 quite soon. I need to know the distance across the middle from E to C. I'll tell you why. If I know, let me just draw it in for you quickly. If I know the length between E to C, like that, I've got an 11.6 opposite height, opposite the C, and I can work out what E to C is using Pythagoras and then divide by 2 to get half the length between X and C. In fact, I think I've slightly overshot the angle there. That's what I need. ACE, there it is. So I need to create that. So again, I need Pythagoras so I can work out this little bit here called X, which is half of it. So let's just do a quick Pythag now. So X is going to be the two shorter sides squared and added, like so, and then just press the square root button and we'll get an answer, shall we? So I've got 8.2 squared equals, and I've got two of these, so just multiply that by 2. I've got 134.48. Press the square root button and that gives me 11.6. So X is 11.6 centimeters. Now that is in fact across the whole lot, 11.6. So I shouldn't really call that X, should I? I'll just get rid of that completely. I'll call it, instead of X, I'll call it EC, which is better. So EC is that, and EC is right across there. Therefore, XC, which is what I want, forget X, just call it XC. It's going to be half of that. And that's going to be, divide that by 2 quickly, yeah, 5.798, so 5.8 centimeters. So let's now, I'm going to write in the 5.8 here, and I think you can see I've got a right angle triangle, I've got an opposite of 11.6, I've got an edge of 5.8, therefore op and edge is all about tan. I haven't really got space to write down here op and edge, but I hope you can see that. That is in fact opposite the angle C, and this is next to or adjacent to angle C, so that should be good. Right, so it's tangent. So tangent of ACE, or angle ACE, is going to be defined as the opposite length, which is 11.6, divided by the adjacent length, which is 5.8, and therefore angle ACE is going to be whatever the shift tan is of that. Well, I know 11.6 divided by 5.8 is 2. Well, try it yourself then. So I'm going to go shift tan 2 equals, there it is, I've got here 63.4 degrees. Is that what we got there? Really? That works really well. Okay, so it's 63.4, getting glitchy again. 63.4 degrees. That is ACE sorted. Now, got to work out angle BAD. Right, BAD. Very, very difficult to see that. Let me try and draw a two-dimensional representation of what we've got there. So this is BAD. So quite hard. And that's what makes it grade A stroke A star. Okay. Right. If that's B at the back, that's that. A is at the top, and coming back to the front here, I've got D. Let's put in what I know to be sure. Straight down the middle is going to be 11.6. So let's just whack it straight down so we can make use of it. Gives us a right angle triangle. So that's 11.6. All these lengths are in centimeters. I know from B to D it's exactly the same as the length from E to C because they're diagonals of the same square. So without any further ado, I want to call BD 11.6 again. So it's 11.6 from there to there, and if I've got 11.6 and I halve it, then this must be 5.8 here and 5.8 there. They want angle, let's go to blue now, ABD. So it's, sorry, AD. So we want all this across here. So if I work out one of them, I can call it angle X now, so that'll be X degrees, say, and that'll be X degrees. I can work out one of the X's and then just multiply by 2. So what have we got? We have got the angle X. Let's work on this side. Angle X has an opposite of 5.8, and it has an adjacent, because that's next to the angle, of 11.6. So you've got op and adj, and that's called tangent. So tangent of X, tan X degrees, is going to be opposite, which is 5.8, divided by 11.6, which is the adjacent, and therefore X is going to be whatever the shift tan is of that. So that's exactly a half, so it's shift tan of a half, 0.5, and that gives me 26.56, 26.56 degrees, and therefore BAD, angle bad, is going to be 2 of these, 26.56, and that's going to be, I'll get to you in a second, 53.1 degrees, and that's it. I just pause now, just check over my working, and I'll get back to you with some AQA questions. Right, carrying on, I'm going to do some of the AQA questions like I said a second ago. Right, this is question 1 on page 277, the exam style question. It says the diagram shows 2 right angled triangles. There they are, one there, one there. AD is 15, CD is 6. Now watch this, this is a really creative question. I love this question. It says here, given that cos X is 2/3, work out the value of sine Y. Where do you even start? Right, this is how you do it. Cosine is defined as op over hype, isn't it? So if you're looking at this triangle here, where the X angle is talked about, the op must be, sorry, the adj over hype rather, the adj has to be the 2, so I'll put a big 2 there, and the hype has to be 3. Now remember, 2/3 is the simplified version of the true lengths AD and the true length of BD. So if you look at it like this, right up here in blue, the cosine of angle X is 2/3, but look at it carefully. If 3 corresponds to the 15, the true length 15, as you can see by equivalent fractions, if I multiply top and bottom by 5, I can see that the true length of the bottom part, the adjacent, is going to be 2 5s, 10. So that is 10 centimeters. Alright, lovely. So I've got an adjacent of 10 and a hypotenuse of 15, and 10 over 15 is 2/3. So I've used my knowledge of proportions to upgrade my 2/3 into 10/15ths, so it's 10 centimeters along your edge and 15 centimeters along your height. So that's a good start. So I've now have a brand new length BD of 10 centimeters, which, if you look very carefully, is the hypotenuse of the triangle BCD. Alright, and therefore the 6 that's given to us is the adjacent to the angle Y. Alright, and I've got to work out what the sine of Y is. Now, what is the rule for sine? Well, if that is Y, then this is its opposite. Alright, and it's opposite over hype. Now, I've not been given the opposite, but I can calculate it, because look, I can use Pythagoras. I've got my 10, which is my hypotenuse, my longest length, and I've got a 6, which is one of my shorter sides. So it's straightforward. Let's just do BC here. BC is going to be 10 squared, the big one, the big one squared, take away the other one of the small sides squared, so it'll be 10 squared, the big one, take away 6 squared, and then you square root it. And let's do it quickly. In fact, I can see the answer is 8. That'll be 100 take away 36, 64. Root 64 is 8. So 8 centimeters. Now, therefore, work out the value of sine Y. Well, how do you do sine? Simple. It's going to be op, well, his op over his hype. Now, what is the opposite? 8 over 10. Now, we can simplify it all the way. 4/5, or we can give the answer as 0.8, doesn't matter. Sine Y is 0.8, And please note how lovely this question is. We calculated, using the rules of trigonometry and Pythagoras, some answers to the questions that are being given us, and we didn't need to shift sign anything, we didn't need to calculate the sign of anything and give a value. It is really straightforward. So that is how trigonometry and Pythagoras can be tested in a non-calculator setting. Now, admittedly, it's Unit 3, so you can use a calculator if you get desperate, but there we go. It's a lovely, lovely question, and that's that one. Now, the last question will be question 2 on the other page, which is going to be a little bit more tricky, I'm sure. Now, prism. Prism, A, B, C, D, E, F, there it is, all those sides there, has a right-angled triangular cross-section as shown below. In other words, it's a triangular prism, so it goes all the way that way, exactly the same. All these are right angles, because it's a right angle triangle, that's a right angle, that's a rectangle at the back there. It's a block of cheese, basically. I've got to calculate the length BD, so let me draw it in for you in rouge. So BD is that one. Great, well, I've got the length of BF, which is 5, and I need to know therefore the length of DF, I think, in order to work out BD. Alright, let's just try this, shall we? Let's carry on with this line facility here. There's my triangle. I want BD, and therefore in order to get BD I must know DF first. Now what have we got? I'm told that this is 8 centimeters across here, so guess what? DC is also 8 centimeters across there. So what have I got? I've got a little line down right angle triangle there, and it's defined as CDF. There it is on the floor. Imagine you're up high looking down on it. That's what makes it grade A or A star. It's tough. So there I go. I've got a little 3D Pythag arrangement type thing. So I want DF now. Let's just do it up here quickly. So DF is going to be 8 squared, 12 squared. Remember, the two shorter sides squared and added. And then you press the square root button. Let's just get the thing on that, the calculation. We've got 64 plus 144 equals 208. Root it, and I get 14.42. So it's 14.42 centimeters. Therefore I'm going to label it in as such. 14.42 centimeters. Now look what I've got here. I've got the triangle BDF ready to go. I have an opposite of 5 and an adjacent of 14.42. I'm not asked to calculate an angle, it's just length. So we're using Pythagoras again in 3 dimensions to work out BD, and we've not touched any trigonometry at all so far. So I've got that and that. It's yet another Pythag. Therefore, DB, which is what we want ultimately, is 14.42 squared plus 5 is the other shorter side squared now. Then just press the square root button. Let's just get an answer quickly. Well, I know 14.42 squared was the previous 208. So 64 plus 144. Yes, it was 208 before I pressed the square root button. So I've got 208 plus, well, 5 squared is 25 plus 25. I've got 233. Now I'm going to press the square root button, and I'm going to get 15.26, but I'm going to call it as a final answer 15.3 centimeters. So I'm going to label that as 15.3 centimeters and just be done with it. That's that. Right, last bit says, hence or otherwise calculate the angle BDF. In other words, now that we've created this lovely little triangle BDF, we want to work out the D angle just there, BDF. It says hence or otherwise. That means I can use the 15.3 I've just calculated and go 5 and 15.3 is the sine of angle D, or I can go 14.42 and 14 and 15.3 and go cos of angle D, or I can go 5 and 14.42, which is the tan of angle D. Why shouldn't I do that? Let's just go for it, shall we? Right. So sine of BDF is going to be opposite, which is 5, all over the hype, which is 15.3. And let's just do that quickly. So 5 divide 15.3 equals, well, 0.3267, etc., etc. Let me just write it down to the last question. 0.32679 7, off it goes. Therefore BDF is going to be the shift of that. Therefore let's just do it, shift and sine. Bam, 19.07, 19.1 degrees. Now, just to show you, it should have worked out a different way. If I go 5 and the 14.42, then I should be playing with tangent. Just see if it works. Do a different colour, yellow. So let's just see if it works quickly. Tangent of BDF is going to be op, which is 5, over the edge, which is 14.42. Let's do it for you. 5 over 14.42 equals, again I'll write it out like I did before, 0.346740.6, and off it goes. Therefore BDF is going to be the shift tan of that, so shift tan is going to give me 19.12. Same thing. There it is. So I've done sine and I've done tan. I could have done cos by going 14.42 over 15.3, etc. So I put that there as an alternative, or of course there is another or using cos, but that's good enough. That's great. Answer 19.1, and that is the end of our trigonometry. Hope you've enjoyed it. I certainly love this topic. I like the way the 3D trigonometry and 3D Pythag all come into play. In fact, if you're going to go for A star, they'll probably give you one of these in Unit 3 where they can test, 2D trigonometry, 2D Pythag, 3D Pythag, 3D trigonometry, and that'll be an A star question worth about 5 or 6 marks. Well, it's not difficult. Just got to watch your step, all right? And we'll catch you in Chapter 19.